of the matrix, our main objective is to find out the eigenvalues and eigenvectors. Okay, so eigenvalues are the characteristic values for any particular system, and eigenvector is the state of that system for that particular eigenvalue. Okay, so we will have one eigenvector for one set of eigenvector for each eigenvalues. Okay, so this problem already solved. I already explained different things in my videos. This is a determinant approach. Okay, so main thing is for these kinds of problem, most of the time you have to find out the equations. I mean, you have to find out the expressions to prepare your equation. I mean, to describe your equation. For an example, that could be given to you, and they will ask you to find out the natural frequency of the system. Okay, so now it's your task how you will do. Of course, the value of K1, K2, M1, and M2 will be given to you, and it could be any type of structure that could be simplified in terms of spring mass system. Okay, so if you see here, there is a book. Okay, I already passed this one to you, the scan copy of the book. So this could be like this: two springs, and then two masses, and one spring is connected here. It could be, sorry, it could be like this also. Three springs, four springs, three masses, both are connected at this both end. So I requested you to calculate these things. Okay, calculate the equations, characteristic equation or the equation that can describe your system. So this is your task. How to describe or how to find it out, I already explained in my video. Watch the video. I have explained it for two spring, two masses, but that can be also extended for this case. And if you have this matrix, this is the matrix we call this, then after getting this value K by M matrix, that is the A matrix in this case, and then you can simplify and solve the problem using any of the three methods. Okay, detrimental determinant method, Federer-Levier method, or power method. So these equations also I explained in my video that just follow my instruction. No need to consider e to the power I minus, e to the power minus, sorry, e to the power I omega t. No need to consider this way. So whatever, however, or whichever I explain, so just follow those things and you will get the same thing. So these are the all spring mass system. Okay, so mainly you have to deal with this because we can simplify any types of structure using this one. For example, this is a two mentioned, so there are two masses, and these are, we have some columns. Okay, so the columns can be simplified as spring with the stiffness that is equivalent to the column stiffness. Okay, the beam can be simplified as a mass. So the beams are supported by columns. In this case, the masses are supported by springs. Is same. And remember that in this case, we have the two spring. Okay, it means the beam is supported by two columns. So two columns are parallel, right? If you have parallel stiffness, so that you need to add this one, K1 plus K2. Sorry, then it's 2K. If it is half K plus half K, that should be K. But for instance, if you have two springs are connected in series, then what will happen? So this one is a different thing. Okay, just hold on. Okay. Okay, sorry for the disturbance. Very big problem. So it means that if you have a spring like this connected in series, okay, if it is K1, if it is K2, then your equivalent K equivalent will be K1, K2 divided by K1 plus K2. Remember, okay, this is like the register. So if your is opposite to the register actually. If your springs are connected in series like this, your equivalent K will be like this. Or if your spring is connected in this way, okay, this is mass, so your K equivalent will be K1 plus K2. Remember the arrangement, okay? So in the book is this form. So that's why you have summation here. Then you can simplify it like this, and then again you have to solve the same problem. Basically, you have to represent your matrix in this way. K by M, and then we have minus, you will have omega square, and we have I, okay, and then we have the unknown vector. For an example, A should be 0. Most of the time you have to express your system in this way. K is the stiffness matrix, M is the mass matrix. Okay, so in this case you will have different types of matrix for depending on the different types of arrangement. In this case your mass matrix or stiffness matrix is this one, K1 plus K2, this K2, K2, and this one is minus K2, minus K2, and K2. So this is your K by M matrix. Okay, if you compare, this one is K2 plus K1 divided by M1 minus K2 by M1 divided by minus K2 by M2, K2 by M2. Because your M matrix is M1, 0, 0, M. M2, sorry. And this is the K matrix and M matrix. So if you know that your stiffness matrix and K matrix, so initially you have to find out the expression in this way, balancing the force. How you balance, I already explained in my video. And then represent and try to find out your stiffness matrix and your mass matrix. If you have these two, then you need to represent this one in eigenvalue form, that is K by M. And in this case, you have, this is the x1, x2, but in my video, as I said, it's actually a1 and a2, okay? So it's not x1 and x2. You can use capital X1. Just continue my video, okay? So then you will understand. And in this case, we consider the lambda is omega square. And this lambda is actually the eigenvalue. So in this case, the eigenvalue is nothing but the square of your natural frequency. Okay. And if you have this one, okay, so then you have to solve the problem. I mean, that you have to find out the value of lambda. So how you can find the value of lambda? So they say that if you have the matrix in this way, A minus lambda I, and you have the X should be 0. So don't be confused with X and A. In this case, A means K by M matrix, okay? In this case, X means A matrix. It depends on the situation. Just focus on a matrix. A lambda is the eigenvalue, and then I is the identity matrix, should be equal to, I mean, the multiplied by some unknown vector. In this case, the unknown vector is A. In this case, unknown vector is X. That should be okay. But in case of determinant approach or determinant approach, you have to find out the determinant of A minus lambda I, and that should be equal to 0. So whatever expression you will get, we call this characteristic equation. Okay, so we call this characteristic equation, and from that equation you will get the value of lambda. So lambda, it could be lambda 1, lambda 2, lambda 3, depends how many eigenvalue you will have, depends on the system. Okay, that's pretty clear. So the main thing is you have to find this stiffness matrix, and it depends on your given condition. It could be 3 by 3, it could be 4 by 4, it could be 2 by 2, it could be a different arrangement. So you have to find these things. Okay. and I ask you to make the matrix here. Okay, so we will do it. If we can do it today, is good. So before going to that, I will just explain the other things. Okay, if we cannot solve today, this one here is your task. Please try to find this expression. In this case, the lambda is equal to omega n square, should be okay. So that should be, you need to consider the lambda minus from the diagonal term according to the definition here, a minus lambda I. So you have to minus the lambda value from each diagonal term. So they did the same thing here. So here, after getting the values, they substitute the value of k1, k2, k3, m1, m2, m3. Simplify it, you will get one values, right? That minus omega, as for that minus lambda, that minus lambda, that minus lambda. Just follow my way, and then you will have this is third order polynomial. So you will have the lambda, three values of the lambda. Okay, and for these three values, you will have these are the states. Okay, so this is the mode 1. Frequencies, its lambda value should be 1.2 square because lambda is omega n whole square, right? And that is the value, the state vector for the second eigenvalue. This is a state vector for the third eigenvalue. So you will get the values. This is omega. It means you will, in order to get the eigenvalue, that should be square of it. So if you just square this omega value, you will get the lambda 1, lambda 2, and lambda 3. Please try to get the lambda values and try to compare with this. Okay. And this can be simplified, as you can see, the 3 spring. Before I had 2 spring, now we have 3 springs. So try to get this expression to make sure you understand how we can simplify or how we can extract the equations. Okay, by balancing the forces. Anyway, then we have some problems how we can get the eigenvectors. So please just follow my lecture. I will not describe here anything here. It's already done. And we have this is the 3 methods. Okay, determinantal method, then we have Faddeev-Lavier method, and then we have the power method. The determinantal method is the determinant. We have to find out the determinant. For Faddeev-Lavier method, we have to follow the strategies that is given here. Okay, so these are some problems. So here is already the matrix already given for the determinant approach. Okay, but most probably you will not get the matrix in this way. You have to find it out for your system. Okay, so let's try to solve this problem. Faddeev-Lavier method, and which problem we should choose. I go back here. Power method. Okay, let's do this. Please try to write this problem. I will not solve. Okay, you will solve, and I will just guide you how to solve. So please write the problem here. We have 4 by 4 matrix. So normally for this method, you have to derive the characteristic polynomial and inverse matrix. So please hurry up if you want to solve this problem. So we have this A, 5, 7, 6, 5, 7, 10, 8, 7, 6, 8, 10, 9, and 5, 7, 9, 10. So when we ask the students to use this method, Faddeev-Lavier method, we ask the students to get the polynomial and also the inverse matrix. Because if you use this method, there's a very, very easy way to get the inverse matrix. Okay. If you are done, so what we do now, then we go to the method, actual method. In this case, you have 4 by 4 equation, right? So the polynomial in your case will be, this is the expression, the polynomial expression. So in this case, your case will be -1 to the power n is the 4. Okay, and then lambda to the power 4 minus p1. Then we have 4 minus 2. Something is wrong, I think. hold on. Some lambda to the power minus n minus 1 is missing here. So just follow the book, okay? That should be lambda cube, then minus p2 lambda square minus p3 lambda minus p4. Sometimes problem, okay? So we have one missing term here. So minus 1 to the power 4, then multiplied by lambda to the power 4 minus p1 lambda cube minus p2 lambda square minus p3 lambda and minus p4. That will be your equation. That should be equal to 0. Okay, according to this method. In this method, you have to find it out. What are the things you need to find it out? P1, P2, P3, and P4. These are the 4 coefficients of the polynomial. You need to find it out. Okay, how to get the inverse? I will talk about this one later on. Okay, so please write down the equation. So your polynomial will be minus 1 to the power 4 is actually no need to write minus 1 to the power 4 because it's actually 1, right? If you have the minus 1 to the power 3 or odd number, then we have negative sign. So whatever it is, just write the values. Now you have to find out the P1, P2, P3, and P4. So we write the equation here. So we know what to do. We need to find out the values P1, P2, P3, and P4. So I hope you understand. You already write it down. So then we go to this one. Okay. So sometimes they use P, sometimes they use C. Is up to you. So we go here. So the matrix that was given, for an example, that matrix was A, okay, the 4 by 4 matrix. So now the B1 is a new matrix, so B1 will be equal to A, the same matrix. You have to write it down. So in this case, your B1 is what? So B1 is, write down the matrix that you already have in the problem, right? Because B1 is actually A. And then you also need to write it down, comma, and then you need to write it down. P1 will be trace of B1. So trace of B1 means what? So I refer to the problem here in the book. So in this case, P1, or you can write B1, is up to you. So any matrix is the A, that is B1 is equal to A, and the matrix, and the trace P1, small p1 is trace of P1. Trace of P1 means you have to add the diagonal values, 12, 16, and 16. You have to add the diagonal values. That will be your small p1. So in this situation, in this case, your values will be, if I go down, the values will be 5 plus 10 plus 10 plus 10. It means 35. Your p1 will be 35. Okay, so I hope you already got your p1. Okay, so if you already got P1, you go to the next step. So your P1 will be trace of B1, and trace of B1 is actually trace of A. Trace of A means you have to add the diagonal element of the A matrix, that is 35. 10 plus 10 plus 10 plus 5. Next, you have the different matrix B. The B matrix is equal to A matrix multiplied by B1. The matrix is already have the B1 is actually A, minus P1 is a constant value, and I is the identity matrix. Okay, so please think about this one. Your new B1, or sorry, your new matrix B2 will be A matrix, that is always common. Then B, if it is B2, is B1 minus this constant multiplied by I. If I refer back to this previous problem, so P2 or B2, whatever it is, A, the same matrix that you have here, then it should be multiplied by the P1, that is the previous one matrix here, minus the constant, it means the P1 value multiplied by identity matrix 1, 1, 1. Now you have to do it. Okay, so, and because we don't have enough time, just keep the things ready, and whenever you are free today, solve this problem, because you need to give the quiz next week, and this week you will have the quiz from system of linear equation, okay, on Thursday. That's always by default. Every week we will have quiz. Anyway, so if you have this one, just multiplied by this, and then this minus this is just subtraction and then multiplication. You know how to do the multiplication. If you don't do, you go to the Google and try to understand how to do the multiplication of the matrix. So in short, you will get the P2. Okay, so make sure that you have this matrix and you know the formulas. And if you know this P2, or according to the slide is B2, then your P2 will be half of trace of B. It means half of then the element, I mean the diagonal element of this matrix. So in this case, your P2 will be half of minus 312 minus 408 minus 408. So your P2 in this case is actually minus 564. They use capital P2, you can use small P2, is up to you. They use similar value. If you don't want to use that, you can also stick with this definition. So similar way, you have to continue B3 and B4. So then you will get P1, P2, P3, and P4. Okay, so you have to repeat the thing. So next time, your B3 will be what? So your B3 will be A. That will be your B2 minus P2I. So you have to multiply this one, this minus this. You have one matrix, then multiply it with this A matrix. This is the multiplication. Then you will again B3. Then you will have P3 will be 1 over 3. Okay, is 2 is 2 is 3 is should be 3. Then trace of B3. That is straightforward, not that much difficult. The method is not difficult. So just you need to know the strategies. Then you will have P3. Then you again continue for P4. So this is a multiplication matrix. If you do the multiplication wrongly, then your answer will be wrong. Okay, so if you have this one P1, P2, P3, P4, then what will have? We will have, for an example, these things. Okay, so just substitute these values here. So in this case, the polynomial in this case will be, this is a 3 by 3 matrix, so this should minus 1 to the power 3. Then we have lambda cube minus P1 lambda square minus P2 lambda cube. Is lambda minus P3. This is your polynomial. So in this case, it's minus. Okay, so in this case, you will have minus lambda cube. Then we have P1. What is the value of P1? That is a problem solved here. P1 is 6. So we have minus minus plus. We will have plus 6 lambda square. Then we will have P2 maybe 11. So that should be minus minus plus. So 11 is actually P2 values minus 11, I think. Yes. So plus minus minus. So we will have minus 11 lambda, and then we will have plus 6. So that should be 0. So then you can write, just shuffle or multiply by minus 1, then you will get lambda cube minus 6 lambda plus 11 lambda minus 6 should be 0. Same. Even you write in this way, it's also correct. So in your case, you have to do the similar way. You will get lambda to the power 4, then you have this expression. So you have to write it down, okay? And from this expression, that is actually characteristic equation, you can solve the value of lambda. Actually, you will get the eigenvalue from this polynomial. So the main objective of the Lebedev-Levier method is to get the polynomial equation. Okay? And after that, you can solve it. You will get the value of eigenvalues. Okay. And how to do the inverse? Because always we ask to do the inverse also in this case. So inverse will be, this is a formula you have to use. You have to remember this one. So A inverse will be 1 over Pn, Bn minus 1 minus Pn. This is the procedure, okay? So in this case, in your case, the example is power 4. But in this case, we have 3 power. So 1 over P3, P3 minus 1 minus this is the values. If you just simplify it, you will get the matrix. That will be your inverse matrix. So in your case, that will be, okay. In your case, is a power 4. So we will have A inverse should be 1 over B4. Then we will have B 4 minus 3. 4 minus 1 should be 3, right? And then we will have this one also same. This should be 4 minus 1, that should be 3, and identity matrix. If you do that one, this minus this, and then divided by this, you will have this matrix that is the inverse matrix. That is easy, okay? So these are not difficult tasks, very, very easy. So the thing is, you have to find out the matrix itself, okay? So in the problem here, in the slide, the matrix is given to you directly, but you will not get these things ready here. And we will not make the things complicated. Mainly we consider 2 by 2 or 3 by 3 matrix. This is just to make sure you can calculate these things, okay? Is there any problem? That's how we solve the Faddeev-Lavier method to get the characteristic equation or characteristic polynomial. Okay, so please try to solve this problem, okay? It's already one solved, one in the examples. But the thing is nothing new. You have to know how to do the multiplication, okay? And subtraction and addition for matrix is very, very easy. So just the multiplication is also easy, of course, but you have to know how to do the multiplications. Okay, so the next method is power method. So power method, we know that we have the eigenvalues, multiple eigenvalues, and also for each eigenvalue we have the eigenvector, right? But among those eigenvalues or eigenvector, we have some dominant pair. So eigenpair means eigenvalue and eigenvector. Together it makes a pair. So normally when we use the power method, we try to find out the dominant eigenvector. Remember, the power method gives you the vector, eigenvector, not the eigenvalue. Eigenvalue later on you can calculate using the formulas. So normally in case of determinant method or Faddeev method, we got the eigenvalue characteristic equation, then we got the characteristic, solve the problem and solve the equation, we get the eigenvalue, and for each eigenvalue we can get eigenvector. How to get eigenvector I already described in my video, so I'm not going to that one. But in case of power method, here we got the eigenvector, and from that eigenvector we can get eigenvalue, okay? And the eigenvector we call it like dominant vector, dominant eigenvector. If you go to the book, you will say that you will see there are two methods, power method and another one is inverse power method. Inverse power method, we try to get the smallest eigenvalues. In case of normal power method, we try to get the biggest or largest values. Okay. Okay, so this one is also very, very easy. And this is actually an iteration method. This is actually an iteration method, okay, remember. So if it is iteration method, you must have the initial guess, and initial guess most of the time should be given. And initial guess for what? Initial guess for eigenvector, because this is the procedure to get the largest or dominant eigenvector. So this is the eigenvector already given to you. And the new eigenvector will be A, that is the matrix, you already know, the coefficient matrix multiplied by the old or initial eigenvectors. Then you will get the new vector. Again, the next new will be the matrix itself multiplied by the eigenvector. This x1 will come here. So we know that ax is equal to lambda x. So we try to find this value. So this one is actually a and x. Okay, so the coefficient matrix multiplied by eigenvector. That will be your the new eigenvector. Okay? So every time we are doing the same thing, and we repeat the thing until we get the eigenvector. This x naught is not changing that much. Okay, so before going to that, we need to normalize things. Okay, we need to normalize things. For example, this is a simple problem for you. Suppose the initial vector is 1, 1. This is the eigenvector, okay? So the new eigenvector will be ax naught. So you will have this one. If you have this new eigenvector, then the next eigenvector will be what? X2 will be your ax1. But before going to that, you know that this eigenvector is 1, 1. But this eigenvector, the new eigenvector is 9, 5, okay? So you must normalize these things. because it's 1 1, this is 9 5, so we cannot compare with this one with this one. So we need to normalize it. How we can normalize? We can select any one values, or we can select the most dominant one. In this case, both are 1, so we can choose any one of it. So suppose we choose this one. So the lower value, right? So lower value means 5. So we need to match this one with this. So how we can match? We divide it by 5. Okay, so we divided by 5, so we have 1, and 9 by 5 is 1.8. Now we have the good comparison. Your x1 normalized value is like this: 1 1, and this 1.8 and 1. So you have to compare it. Okay, so you have to compare. Normally we consider with respect to the biggest value. So if you have normalized this one, then when you use this one, you will use here is actually x prime, normalized one. So then it will continue. Every time you got this one, you have to normalize one. And if you normalize one, the first one with the lower value, you have to consider the same strategy, because you need to compare the things, right? So every time you make it normalized, and this is the new vector. So this one is 11.4 divided by 5.8 here. Same way. So this one 11.89 divided by 5 point something here. So this one is normalized, and every time we repeat the same. And you can see that these are the vectors, right? These are the eigenvectors. So these eigenvectors are actually almost same, 1.9942, 1.99 something. So we can say that the eigenvector is actually reaching to the convergence, and it could be 1 and 2, approximately 1 and 2. Normally you need to calculate the error, because this is the iteration process, and the error, you already know that current state, the current value minus previous value divided by current value, that will be the error for this iteration. Okay. Okay, and the way we calculate the transpose is using this formula. The way we calculate the eigenvalues. Okay, so this is eigenvector. If you already got the eigenvector, so the eigenvalue will be like this. So normally we have x is equal to lambda x, right? So lambda is actually, you know that a x, right, divided by x. This is the value. Then what we do, we try to use the transpose up and down, x transpose. So if you do the x transpose here and then just solve the problem, you will get lambda. Same problem, okay, using this equation. So if you have this one and then calculate the value, you will get the lambda for that particular eigenvector. Okay, so please try to solve this problem. This one. So we have 1, 1, 1, 1. So it's all, again, you can choose any of it. So we have 15 minutes, right? Just we will try to solve this one. Before going to that, there are some problems here. For an example, okay, power method. So in this case, the power method, if you see the book, you will say 1.5 minus 0.5. Okay. So in this case, the biggest value is 0.1. So they prepared the table here. If you don't want to prepare the table, also okay, no problem. You can follow the slide. So the initial values are, in this case, 1, 0.5 and minus 0.5. Then you get the value, the new value that will be, the matrix will be 18, 13 and minus 13. Then you need to normalize this one like before, divided by 18, because 18 is the first element, because this is the 1. So we try to compare with the biggest value. So we try to always consider it 1. Okay, so if you want to compare it with 1, so you have to divide it by 18. So 13 by 18 is this value, minus 13 by 18 is this value. If you don't want to stick on this tabular form, you focus on the slide. Okay, the same thing. So which one you have to choose? Before, in the slide is 1, 1, so you can choose any one. But if you are here, you have to choose the largest value, that is 1. The first element, so you have to compare with the first element. So in this case is 1, I have to compare 18 with the 1, so I have to divide it by 18. So each time you need to divide it the first element by the first element to the all the elements. Okay, it means 16.11 divided by 20.66 minus 16.11 divided by 20.66. Every time you will get modified values. So if you compare, you can stick with this one, or if you don't want, you can also stick the strategies that is mentioned here. Okay, so let's try to solve this one, because now we have 15 minutes. At least we do some 2 or 3 iterations. Please write it down. This one I already asked you to write it down. Then I gave you the basement. Okay, right? So you just follow the instruction. And for now being, just we can write it down here. How much is the so your, if your A is here, X is here, so your X1 will be A, and then we have X. For example, this is X naught. Okay, so what will be the value? Can you say me the vector? I open the chat box. Attendance later, because you came late. Okay, anyone want to say anything? You can say, no problem. Unmute and say, or you can write it down. So now we are trying to find out the new vector, that is A multiplied by this. So try to multiply this one and let me know what are the values here. Quickly, what is the first value? You need the multiplication. You know how to do that? 5 multiplied by 1 plus 4 multiplied by 1 plus 1 multiplied by 1 plus 1 multiplied by 1. So how much? Why you need time? It's all 1, is simplified. You know, huh? 1 is, no. Where is the 1 over x? This one is A multiplied by x, not 1 over, is vector. Don't believe like what I write, just believe what I say. Okay, sometimes it's difficult to write digital board. Okay, so you will have 11 11 8 8. Okay, 11 11 8 8. So which one you want to normalize? Normalize with respect to 11. So if you want to normalize with respect to 11, okay, so what you will have? Then x1 prime 1 1 8 by 11, how much? Okay, 0.727. 0.727. Okay, so if you've done this one, next is you calculate the x2. X2 will be A, and this x1 normalized one prime. How much? So 5 multiplied by 1, 4 multiplied by 1 plus 0.727 plus 0.27. Okay, 10.454, 10.454, 6.362, 6.362. Now again normalize with respect to the first one, 10.454. So you will have, I don't have the space, so I am writing here. Okay, which one? 609 is where? Oh, okay, understood. So that should be 1 1 0.609, you mean 0.609. So you need to continue, okay, like this. and then you will have what? X3. X3 will be A multiplied by X2 prime. So continue, okay? Continue until the error. Okay, there will be some tolerance. Tolerance, how you will get the tolerance? Tolerance will be the error, okay? For this stage, the error is how much? The error will be 0.609 minus 0.727 divided by 0.609. So you will get the error. And you will feel that whenever even you continue the iteration, this the vector, that is the vector, right? This is the answer actually. Not the answer, I mean it's modifying. You start with 1111, but you have this 11.609609. So that will be modifying again and again and again. And at last you will feel that is not modifying that much. Okay, that will remain persistent or consistent, even though you continue your iteration. So your answer will be that one. Okay, your answer will be that one. So just continue that one. That's not difficult. For me, is the easiest part of this numerical method. Just you need to solve the matrix way. Okay, so I hope you continue, and also I hope you try to solve this method using the FADM method, and you can share to the group so I can also have a look. Okay, please try to solve these two problems, and as I said, if you can follow the book using the table, or you can follow my way. So just do it, and then at last you need to prepare the table. Okay, at last, please. So do we until we got a constant? Just repeat, and you, because in this is the practice problem. Okay, in the exam or in the classes, they will be given some tolerance limit. So if you feel that the values are not changing that much, for an example, 0.609, and again you repeat, again you got 0.608, again if you repeat, even you get 60 maybe 85, so then you stop. Okay, then you will have the idea that you are doing the repetition, but there is not that much change. But here is a change, right? 0.727, then it becomes 609. If you repeat, and you will see that after some time, the value will not change. It's same like iteration process. So normally we give the tolerance limit or acceptable error limit. In that case, the value is, no. You need to consider the 3 digit or 4 decimal points. Yeah. You have to compare with the tolerance and continue the iteration. Whenever there is iteration, you must continue until the tolerance limit, or if the examiner said like do the iteration up to just consider 5 iterations, 6 iterations, then you just consider that amount of iteration and that number of iteration, and then you can write it the answer. Okay, it depends. So normally we have the termination condition, because the iteration you must stop, otherwise there will be an never-ending process, right? Okay, so the main things are, I request you to solve, the way we solve is easy. Okay, there is another one, 4.5 is this is the smallest eigenvalue. So normally we consider only the power method, not the inverse power method. Okay. We consider only power method, but also I explained this one in my video. So if you are interested, you can have a look. But make sure you can derive this one, derive these things, all the formulas. I mean the expressions. K by M matrix. Okay, K by M matrix. You must have those things. For different arrangements. So please try to solve the problems that is mentioned in the book. So this one, you have this one. Okay, so try to read the problems and try to solve those things. So I hope you will get something similar in the class test also. Okay, mainly we try to give the spring mass systems. Okay, then the values are given, simplify it, compare with the eigenvalues, do the first 3 iterations. You can see after 3 iterations, so it's already mentioned that you just consider 3 iterations, then compare your value with the value that you got from which method. They said like which method. Okay, power method. Okay, they have to use the power method. Part B, determine all eigenvalues analytically. Analytically means characteristic equation. Okay, determinant approach. Determinant approach is the analytical approach. And then FEDEF and then this power method is a like numerical approach. So what is the natural frequency in hertz, and then what is the largest eigenvalues of the spring mass system of the above. So largest eigenvalues, it means the value that you got after the power method, that is the eigenvector. So for that eigenvector, you have to find out the eigenvalues. So how to get the eigenvalues? Can you share back the question for section 4? Which one? Section 4. What do you mean? This one you already have. This one in your. I already uploaded it in your e-learning, so you can download it. You mean this one? You can download these things from your e-learning. It's already there. Okay, so if you still have problem, let me know. But I don't think you should have problem if you really try to understand. Okay, but the methods, the way of solving is very easy and straightforward. And just you need to get the mass matrix and stiffness matrix. That's the two things that you have to know for any types of system. Okay. Okay, the attendance. Okay, so this one you already in the e-learning, so you can get these things. So don't worry. Okay, I just share the attendance. Then maybe you can. And remember that we will have the class test on Tuesday. Okay, so hold on. I try to share the attendance. Those who fail to give the attendance.